Okay, we're starting with number 22. Find the vertex of the parabola. So that's the high point. Now you could always graph it and find the vertex that way. Or we can use x equals negative b over 2a to find the x coordinate of our vertex. So for this one, b is negative 12. So if I were to do the negative of b, that'd be a positive 12 over 2 times 2. So 12 over 4 is 3. So my x coordinate is going to be 3. And so my answer is going to have to be a. But let me just make sure. If I plug in 3, 2 times 3 squared minus 12 times 3 plus 16 is 18 minus 36. I don't know why that says 136. Minus 36 plus 16 is negative 2. So my answer for the vertex is 3, negative 2. Number 23. Find the axis of symmetry. Well, that's just the x-coordinate of the vertex. That's where this splits this parabola in half. So it's, again, x equals negative b over 2a. So that's going to be negative 8 over 2 times 2. So negative 8 over 4 is negative 2. X equals negative 2 will be the axis of symmetry. Number 24, determine whether there is a maximum or minimum value and find that value. Well, this starts out with a negative x squared, so it means this parabola is opening downward. If your leading coefficient, which is your first, your a, if your leading coefficient is positive, your parabola opens up. If it's negative, your parabola opens downward. So we're going to have a maximum point here somewhere, and it's going to be at our vertex. So x equals negative b over 2a will give us the x value, and then the y value will actually be our maximum. So negative b over 2a for this problem would be 8 over 2 times negative 1, so I get negative 4. And when I plug in negative 4, then I get, this would be negative 16 plus 32 minus 26. Let me try this on the calculator here. Negative 16 plus 32 is 16 minus 26 would be negative 10. So my maximum point, this point right here, is negative 4, negative 10. So my maximum value is the y. Remember, the maximum is negative 10 when x is negative 4. So my answer is A. The maximum is negative 10. Number 25, John owns a hot dog stand. He has found that his profit is represented by the function p of x equals negative x squared plus 74x plus 80, with p of x being the profits and x the number of hot dogs sold. How many hot dogs must he sell to earn the most profit? So basically, again, this is got a negative for my leading coefficient. So this is what the graph of this hot dog function is going to look like. X is the number sold, and then the y would be how much profit he makes. So he wants to find where is he going to have the highest profit. So again, we're looking for the vertex. So x is equal to negative b over 2 times a, which would be 37. So it's 37, and they don't ask me what was that profit. They just want to know how many hot dogs does he have to sell to make that profit. So 37 hot dogs is going to give him the most profit. 26, the number of mosquitoes in millions in a certain area depends on the June rainfall. The X is the rainfall in inches, and the mosquitoes would be the M, what we get in millions. What rainfall produces the maximum number of mosquitoes? So again, this is opening downward, and it's actually, if I write it in descending powers of the variable, it's a negative x squared plus 3x. So I'm again finding the vertex. So x is equal to negative b over 2 times a. So that's going to be 1.5 inches would give them the most rainfall. And they don't ask how much the rainfall is. They just want to know what's your x value that's going to give you, 1.5 inches, that will give you the most, not rainfall, that will give you the most mosquitoes. And so that they don't ask how many mosquitoes you're going to have. They just ask how much rain would you need to get. So that is my answer. 27, the length and width of a rectangle have a sum of 84. So I don't know, but one of these sides is going to be x and the other is going to be 84 minus x. Length and width add up to 84. What dimensions give the maximum area? So length times width, and what I want to do is I want to graph this, and I want to find the maximum point here. So looking for, again, the vertex, negative x squared plus 84x equals y. So x is equal to negative b over 2 times a, which is 42 for x. So that means this side would be 42 and this side would be 84 minus x, which is also 42. So if the rectangle, or really a square, is still a rectangle, and it's 42 by 42, it would give the maximum area. 28, we have to find our LCD. So this is y plus 5, this is y minus 5, and this is actually y plus 5 and y minus 5. That's how y squared minus 25 factors. So I'm going to multiply everything by both y plus 5 and y minus 5. And what happens when I do that, y plus 5, y minus 5. Here the y plus 5's cancel. So it's 8 times y minus 5, which is 8y minus 40. And here, if I had the y plus 5 and the y minus 5, the y minus 5's would cancel. And here you have to be careful. It's minus 2 times y plus 5 is what I get, which would be, I'm going to write the 8y minus 40 down, it would be minus 2y and minus 10. Be careful. And then here, if I had the y plus 5 and y minus 5, everything would cancel, and I would just have 10. So 8y minus 2y minus 40 minus 10, so that's 6y minus 50 equals 10. Add 50, 6y equals 60, so y is equal to 10. And make sure that you can plug it back in and that would work, okay? It wouldn't make the denominator 0, and it looks like it would work okay, so my answer to 28 is A. 29, I have 1 over 2 plus 1 over 6 equals 1 over t. So the first thing that 2, 6, and t would all go into is 6t. So I'm going to multiply everything by 6t. So here, 2 goes into 6 3 times. Whoa, I moved that. That's not good. I don't know if I can bring that down. I don't know if I can figure that out. No. So anyways, it's times 6t, so that the 2 goes into 6 3 times. So 3t times 1 is 3t. And then here the 6's would cancel, and I know you can't see that, but that was 6t. This is 6t. I'm going to write it again so you can see it. So the 6's cancel out, so it's just 1 times t equals, here the t's cancel out, and I just get 6. So 3t plus t would be 4t is equals 6 divided by 4. T equals 3 halves, 6/4. 3 halves, 1.5. My answer would be C. Number 30. The square root of 4q plus 5 equals 5. Just square both sides. So this side it just removes the square root. And this side you get 25. Subtract 5 from both sides. You get q is equal to 5. Make sure you can plug it back in and it really works. 4 times 5 is 20. Plus 5 is 25 squared. That's 5. So it does really work. So my answer is D. Let's go a couple more. 31. We've got a cube root of 4x plus 7 equals negative 3. Cube roots can be negative, so this one's doable. Cube both sides, which on this side that removes the cube root. Negative 3 cubed is negative 27. Subtract 7 from both sides, you get 4x equals negative 34. Divide by 4. X equals, what would that be, negative 8.5, and they're going to call it negative 17 halves. So my answer is D. Number 32, before I do this one, I have to isolate the square root. So it was y square root of y minus 7 plus 4 equals 0. So when I move that over here, it becomes the square root of y minus 7 equals negative 4. You can't have a square that equals a square root that equals a negative number. And I'll show you why. Let's just say we solve this the regular way. The answer is going to be no solution. I can't have a square root equal to a negative. So if I were to square both sides, here's what would happen. I'd get y minus 7 equals 16. Add 7, you get 23. Well, plug it back in, 20 into this problem. Square root of 23 minus 7, so that'd be the square root of 16 plus 4 is equal to 0. And that's not true, because that'd be 4 plus 4 equals 0. It doesn't work. You can't have a square root equal to a negative. So my answer here is no solution. All right, I'm going to pause it here because this problem is going to take me a little bit longer, and so that's where I'll pick up with the next of it.